Welcome back to the Explainer. You know, every piece of fabric you own, from the shirt on your back to the curtains in your room, holds an incredible secret. Today, we're going to peek inside the machine to find the hidden mechanical heart that turns simple threads into works of art.
I mean, have you ever really looked closely at a piece of patterned fabric and just thought, how did they do that? It can seem like pure magic, but it's not. It's actually a brilliant piece of engineering that solves one single fundamental problem.
And that solution has a name: shedding. This one action is the key to, well, pretty much everything. And understanding it is where the story of all modern weaving technology really kicks off.
Okay, so let's get right into it. To really appreciate the genius of shedding, we first have to wrap our heads around the basic challenge of weaving itself.
So picture this. You've got hundreds, maybe thousands of threads. The warp, stretched out super tight, kind of like the strings on a harp. Now, the big challenge is, how do you take another thread, the weft, and weave it over, under, all the way across thousands of times without losing your mind? And here is the aha moment, the big, elegant insight at the heart of every loom. Instead of trying to painstakingly snake that weft thread through a static grid of warp threads, you just move the grid itself.
And that's it. That action of lifting some threads and lowering others is shedding. It creates a little tunnel, the shed, and the weft thread can just shoot right through. But here's the kicker. How a loom performs this action, how it decides which threads go up and which stay down, well, that determines everything. It's the difference between a plain bedsheet and a priceless tapestry. So let's start with the simplest method.
We're going to start with the absolute workhorse of the weaving world. This is level 1, the tappet mechanism. This is the engine that creates most of the simple fabrics that we use every single day.
The beauty of the tappet mechanism is just how simple it is. At its core, you've got this rotating, lumpy-looking piece of metal called a tappet. As it spins, its weird shape pushes down on a lever, creating a super predictable up and down motion. And that motion pulls on this frame, called a heeled shaft, lifting an entire group of warp threads all at once. Simple, effective.
And you know, what's really cool is that even in this simple system, engineers came up with some clever variations. You've got the negative tappet, which just pushes down and then relies on something like a spring to pull the shaft back up. But then you have the positive tappet. See that groove? It physically controls the lever both up and down. That gives you way more precise control, which is absolutely crucial if you want to weave at super high speeds.
So here's the bottom line on the tappet. It is a beast when it comes to efficiency. It's fast, it's reliable, it just churns out fabric. But because that motion is fixed and repetitive, you're pretty much limited to basic patterns. It's perfect for making denim or simple sheets, but you're never going to weave a picture with it. So what if you want to do something a little more complex?
Well, that brings us to level 2. Enter the Dobby mechanism. This is where things get a whole lot smarter, because we're adding a layer of what you could call programmability to the loom. Remember how the tappet loom could only handle a few of those heeled shafts? Well, a Dobby can control up to 24, sometimes even more. That is a massive leap forward. All of a sudden, you can create small, intricate, repeating geometric patterns. Think about the texture on a polo shirt or the decorative border on a dish towel. That is Dobby territory.
So how does it work? Well, you can think of it like a mechanical code reader. Instead of a simple cam, there's a pattern chain or a card that tells the machine which hooks to engage for each line of the pattern. Then, these moving blades, or knives, come along and grab only the selected hooks, lifting just the right set of threads. It's a selection system, not just a simple repetitive motion, and it allows for way more variety. But even this has its limits.
What if you wanted to go beyond those small geometric patterns? What if you wanted to weave an image with curves, with shading, with any design you could possibly imagine? To do that, you can't just lift big groups of threads anymore. You need a truly revolutionary leap in technology that gives you absolute, total control.
And that brings us to level 3, the jacquard mechanism. And I'm telling you, this wasn't just another improvement. This was a complete game changer, an invention that not only transformed weaving, but incredibly helped lay the groundwork for modern computing.
The absolute genius of the jacquard is right here in this diagram. The first thing to notice is what's missing. There are no big heeled shafts. Instead, you've got this incredible, complex system of individual hooks and needles, all controlled by that cylinder. The whole point is to achieve individual thread control. This is the ultimate power for a weaver.
And this is the part that literally changed the world, the punch card system. You've got this long chain of cards, and each card is basically a line of code. When a card is pressed against the needles, if a needle finds a hole, it passes through, its hook engages, and that specific thread is lifted. If it hits a solid part of the card, the needle is pushed back, the hook stays disengaged, and the thread stays down. It's binary. A hole is a 1, no hole is a 0. Lift or don't lift. And this idea, using binary information on a punch card to control a complex machine, was a direct inspiration for the earliest computers. This isn't just a Loom. You're looking at an ancestor of your laptop.
So the crucial point here is that this wasn't just a small step forward. It was a total paradigm shift. The jacquard mechanism just blew the lid off what was possible, allowing weavers to create patterns as intricate as a photograph or a detailed painting.
Okay, so let's zoom back out now and bring this all together. Let's see how these 3 incredible levels of technology show up in the fabrics that we see and use every single day. This table really says it all. The shedding mechanism, the brain of the loom, is what directly dictates the complexity of the fabric. You've got the tappet for high-speed simplicity, making things like your denim and bed sheets. You've got the dobby for those small, neat geometric designs on your polo shirts. And then you have the jacquard for, well, for literally anything you can possibly imagine.
So the next time you see a piece of fabric, I want you to really look at it. Look at the pattern. Because now you can see the story of the technology that made it. You can see the ghost in the machine, whether it's that simple rotating cam, that clever mechanical code reader, or that complex programmable machine that helped kickstart our modern digital world.
And that brings us to right now. The principle of shedding, it's still there, but the tools are evolving once again. The punch cards are now pixels on a screen. The mechanical hooks are now tiny digital actuators. It really makes you wonder, what are the weavers of tomorrow going to create? Because we're not just talking about creating new patterns anymore. We're talking about weaving technology itself into the fabric of our lives, creating textiles that can sense, react, and communicate. The revolution is far from over.